Welcome to the DIY Honda Garage channel. The DTC P2135 indicates an issue with the throttle position TP sensor in the Honda Fit, specifically referring to an incorrect voltage correlation between TP sensor A and TP sensor B. This diagnostic trouble code triggers when the voltage readings from these two sensors fail to correlate as expected during engine operation. The TP sensors play a crucial role in providing the engine control module, ECM, with real-time data on the throttle position, which directly impacts engine performance and efficiency. These sensors are typically located on the throttle body assembly, which is situated at the intake manifold, where the air enters the engine. A malfunction in either of these sensors can lead to performance issues such as reduced engine power, increased emissions, or stalling. Addressing this error requires a methodical approach to identify whether the sensors, wiring, or the engine control module itself is at fault. In DTC P2135, the problem centers around the function of the throttle position TP sensors A and B, which are critical components in the vehicle's throttle control system. These sensors communicate the position of the throttle plate to the engine control module, ECM. As the sensors report inconsistent voltage levels, this can signify a fault in the data being relayed to the ECM, which can have serious implications for engine operation. The sensors are located on the throttle body, which is typically situated near the intake manifold. Their role is to help optimize engine performance and emissions by regulating how much air enters the engine based on the driver's input. When there's a disparity in the signals from these sensors, it can lead to performance degradation, making it essential to diagnose the issue accurately. Several factors may lead to the triggering of DTC P2135. First, a common cause is defective throttle position sensors A and B themselves, which can either be worn out or have internal faults, causing erroneous voltage readings. Secondly, wiring issues cannot be overlooked. Loose or damaged connections can disrupt electrical signals between the sensors and the engine control module, resulting in the DTC. Another potential reason for this error could be a malfunctioning engine control module, which may fail to interpret the sensor signals correctly. Each of these causes needs to be carefully investigated during the diagnostic process, as they can lead to significant engine performance issues if not addressed promptly. When DTC P2135 is triggered, there are several symptoms that a driver might observe in their Honda Fit. One primary sign is a noticeable reduction in engine power, which can hinder acceleration and overall vehicle performance. Additionally, drivers may experience poor throttle response, meaning that the vehicle does not accelerate as expected when the gas pedal is pressed. This can lead to an unsatisfactory driving experience and can be particularly dangerous in situations requiring quick acceleration. Moreover, the vehicle's onboard diagnostics will likely trigger the check engine light, alerting the driver to a problem that requires attention. Recognizing these symptoms early can be crucial in mitigating further engine issues and ensuring the vehicle runs smoothly. For the first step in troubleshooting DTC P2135, you must verify the problem using the Honda Diagnostic System, HDS. Start by turning the vehicle to the on mode without starting the engine. Once in this position, use the HDS to clear any DTCs that may have been previously recorded. This process allows you to establish a clean slate for further diagnostics. After clearing the DTC, select the ETCS test option from the inspection menu on the HDS. Here, you will check for any pending or confirmed DTCs. If DTC P2135 shows up again, you've confirmed that the problem persists, indicating that further troubleshooting is necessary. If it does not appear, this could suggest an intermittent issue or a temporary fault, prompting you to check for poor connections or loose terminals that may have contributed to the inadvertent triggering of the DTC. The second step involves determining where the failure lies within the system. Start by turning the vehicle to the off or lock mode. Next, use the HDS to jump the SCS, short circuit switch line, allowing you to engage in further testing without interference. After waiting for over a minute, disconnect the PCM Powertrain Control Module connector B, specifically connector pin B, 51P. This connector serves as the communication hub for sensor inputs and the ECM. Once disconnected, you will need to check for continuity between specific test points, specifically pin 46 and pin 47 on PCM connector B. If continuity exists between these test points, it confirms that the wiring is correct and directs you to the next troubleshooting step. Conversely, if there is no continuity, it indicates a potential issue with the wiring or the PCM itself, warranting further investigation or replacement of the PCM if it's determined to be faulty. In the third troubleshooting step for DTC P2135, the focus shifts to checking for possible short circuits in the wiring. Begin by disconnecting the throttle body 6P connector, which links the throttle position sensors to the PCM. With this connector disconnected, you will again check for continuity, but this time, specifically between both test points on the PCM connector, pin 46 and pin 47. Ensure that the vehicle remains in the off or lock mode during this process. It is crucial to measure the resistance between these two connections, and you are looking for a resistance value of 1 megaohm or greater. If this condition is satisfied, it confirms that the wiring between these terminals is intact, suggesting that the issue may lie within the throttle body itself, thereby necessitating its replacement. If the resistance is lower than 1 megaohm, it indicates a short circuit between THL1 and THL2, which will require repairs to rectify the wiring issue. After performing the necessary repairs in relation to DTC P2135, it is vital to conduct a final verification to ensure that the issue has indeed been resolved. Begin this process with a test drive, allowing the vehicle to reach various operating conditions, similar to those when the DTC originally triggered. During this test, pay close attention to the throttle response. It should be smooth and immediate, without any hesitation or loss of power. Once the test drive is completed, you should again use the HDS to check for any recurrence of the DTC. If DTC P2135 does not reappear, it indicates that the issue has been successfully resolved, validating that the repairs made have reinstated the proper functionality of the throttle position sensors and associated wiring. This verification acts as a final confirmation to ensure safety and optimal performance in your Honda Fit. To prevent the recurrence of DTC P2135 in the future, establish a routine for preventive maintenance focused on the throttle position sensors and associated wiring. Regular system checks are crucial to ensure that all components, including sensors and connectors, are functioning as intended. During these checks, pay special attention to inspect wiring connections for any signs of wear, corrosion, or loosening that could eventually lead to faults. Equally important is the timely replacement of any identified faulty sensors to avoid potential performance issues down the line. Implementing these preventive measures can help maintain optimal vehicle performance and avoid unexpected breakdowns, ensuring your Honda Fit remains reliable and efficient on the road. In conclusion, understanding DTC P2135 is essential for maintaining the performance and reliability of the Honda Fit. This code highlights a fault related to the throttle position sensors A and B, which are critical for regulating engine airflow and throttle response. Key components involved in the troubleshooting process include the sensors themselves, wiring connections, and the engine control module. Proper troubleshooting must be followed meticulously to identify the exact issue, whether it is a sensor malfunction, wiring problem, or PCM failure. Addressing the code not only resolves performance issues, but also ensures that the vehicle operates efficiently, improving fuel economy and reducing emissions. By implementing preventive maintenance practices, you can significantly decrease the likelihood of future DTC occurrences, contributing to the overall healthy operation of your Honda Fit. Please like and subscribe to the channel. See you next time.